Okay, we're doing a little review for our test coming on Monday, and that test is on sequences. That's our chapter 9, uh, and basically, or unit 9. We can give you your problems in 3 different ways. There's graphs of sequences, and on this problem, I've given you a graph. I've given you the first 2 points that go on the graph. Or sometimes they don't deal with graphs at all. They just give you a sequence, and they say, 10, comma 20, comma dot dot dot, and you gotta create the rest of the sequence. If I just gave you 10 and 20, do you get that you can't tell whether it's adding or multiplying? It could be add 10 or it could be multiply by 2. It's one or the other. And if I say it's geo, though, I'm saying geometric, that means it's a multiply problem. Okay. By the way, if it's a multiply problem, is it going to have a common ratio or a common difference? Ratio. All right, good. Okay. What I asked you to do on this one was to make the graph, and if you haven't already, make the recursive equation. U sub 1 equals blah, 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 u sub n minus 1, the whole recursive equation. All right, well, you maybe finish up your recursive equation. I'm going to remind you what the graph would look like. All right, I have to number this along the side. Now, this is kind of subjective. You can number it any way you want to, but I'm going to go by tens. 10, 20, 30, 40, 50, 60, 70, 80, etc. Okay, so this spot right here represents 1 down here, which is the n, which is like that, and 10 on this scale, which is like that part. So that's the point 1, comma 10. The next one would be the point 2, comma 20. You just take the u out, and it's pretty self-explanatory, pretty intuitive. So 2, comma 20. From right there, though, any 2 points, if they're on a straight line, it's simple, but if they're on a curve, you don't know exactly what the curve looks like till you make the next point. And 3, comma, I got to double the 20, right? Because if you figured out the common ratio is 20 divided by 10, which is 2, I'm doubling every time, so I got to go 3, comma 40. It's really hard to tell that that's turned, but it has. Part of it is because my spacing along the bottom isn't perfect. This space is kind of a long gap, so it's throwing it off a little bit. And then 4, comma 80, and then I've gone off my graph. But do you see how this thing creates a curve? That's a sign you got geometric growth. You ever heard of exponential growth? It's kind of like that. It's actually the exponent would be 2 to the power of x if you're doing an exponential. But anyway, so this is it's got a nice curve to it. If I had been adding 10 each time, would it have a curve? No, it would be straight. If I was adding 10 each time, it would just go up 10 every time, and it would have gone off like that. Okay, so then the formula, you should have had u1 equals 10, and un minus 1 times, and then 1 plus 1 is what I would recommend. You're multiplying by 2. Do you have to do it that way? No, but here's what you probably would do wrong if you just said 2 here. If you say times 2 here, and then I ask you what percent growth is it, do you get a lot of people would say 200% growth? And that's wrong. It's not 200% growth. All right. It is. If I put 1 plus 1 here, which is, of course, equal to 2, it's still an indicator that says that is my growth. My growth is 100% growth. That really is a confusing thing. If you say double something, doesn't it seem like it went up 200% because of the double, the 2 in it? But when you double something, you're really only going up 100% over what you used to have. Okay. All right, and the last thing is, did you remember n is greater than or equal to 2? Who all remembered that? Awesome. That's going to be important, because if you don't have that, you're going to lose some points. I don't know. Might be 5%, might be 10%, but hey, why lose points for something dumb like that? Okay, now why did we start with u sub 1 on this kind? Because it wasn't a what? A real life problem. Because in a real life problem, we would want our starting number to be 0, because then it's like before we started the experiment, it's like time is 0. Okay, so u sub 0, this is like time along here. sort of. It can be anyway. That's where you would put time if you were going to put it on one of the two axes. And if you want time 0 to be like your start, u sub 0 is a good idea. All right, let's jump to a real world question. See if you can handle this one. I have $1,000. I put it in the bank and they give me 2% interest. Write the equation for that. Right away, I'd say U0 because it was a real world problem and it works better with U0s. And it was $1,000. And then U sub n is U sub n minus 1 times 1 plus 0.02 n greater than or equal to 1. Raise your hand if you had that. Awesome. Okay, now let's actually put that in the calculator. After 25 years, how much would your $1,000 have grown to? After 25 years. Get my calculator going here. I guess I should probably pause while I try to do that. Okay, here's my calculator, and the last problem I did had a year of 2006 as its U sub starting number. Now again, be careful on this. If I change this to U sub 0, which is what I want to do, I also got to remember that my table the last time I used it was in like the 2000s. So do you get, if I go to my table, it's going to start numbering in the 2000s probably. So that's a really common thing for kids to freak out because they go to their table and they're like, these numbers don't make any sense. It's because you're not looking at 0, 1, 2, and 3 in your table. So anyway, you can set that with table settings. All right, this one happens to be 3% interest on this last problem I did. And I'm changing that to 2. And then I'm going down here and putting $1,000 in. And now I can go to, I'm going to go to my table settings right off the bat. See, it was starting in 1985. I want mine to start at 0 now. And now I'm going to go to my table. One way I could have prevented that problem is skip the table altogether. Get that I don't even need the table, really. I can just, instead of arrowing down a whole bunch of times, I can go U sub 25. And there it is, 1640.6. And actually, if I was going to round it in dollars, in pennies, I would say, and 61 cents. Raise your hand if you would have had that right. Okay, good. Now, let's do a few easier ones, back to just like little term stuff. Let's say it says this, U 2004 is equal to 200 people. There's 200 people in this town in the year 2004. U sub n minus 1 times 1 minus 0.3. Yeah, it's hard to read. 0.2. Okay. There, and other than a domain, I've got everything I'd need. Would you tell me, and we're going to do some terminology here now. What is this an arithmetic or geometric? Does it have a common ratio or a common difference? What is the common ratio or common difference? And what is the rate, which is different than the common difference? Try to answer those 4 questions about this. Okay, in a moment. I'm going to pair up people here. I'm going to pause for a second while I do that. Okay, so see how your partner did out of 4 points possible. Okay, so here's how I would have graded my partner. First of all, do you agree that even though it's not shown, this is implied that there is a multiply right there? Do you get that? Because otherwise, if I said it was a 2%, or I didn't even say what percentage it was. I just wrote that, okay? But it was a decrease in the population of the town. Now, again, I probably should put it there, but do you know if you actually do this with a calculator, you don't even have to have the multiply there, it'll actually work. So anyway, I would recommend the multiply so that you're clear on what you're doing. But that makes it a geometric. Okay, the next one. If it's geometric, then that automatically goes with a ratio. Okay, this kind, a common difference, that's where you're subtracting something every time. Here we're multiplying by something every time, multiplying by a ratio. And it's the ratio of this number and the next number. Okay? All right, 200 and the next number. Common ratio, common difference. Therefore, this is a common ratio. And what is the common ratio? That is the whole thing right here. 1 minus 0.2, which is 0.8. And then the last part is the rate. And don't say 80%. The rate is not the whole thing. The rate is just this part. And if you said 20%, you were on track. Now, if you wanted to say 20% decay, that'd be fine. All right, if you wanted to say negative 20% instead of saying decay, that would be fine. But what you don't want to say is negative 20% decay, because the negative really isn't even supposed to be there. It's just 20%, and you're supposed to say decay. Okay. Any questions on that? Sir? Sure. The only thing you're using the 0.8 for is if they ask you what the common ratio is. It's different than the rate. The common ratio is the whole thing, and that's the 0.8. And the 20% decay, that's the rate versus the common ratio. Does that answer your question? Good enough? Okay. I'm going to give you another one that's similar, and you can maybe see if this works for you. All right, so let's say that we take attendance at the football game here at the high school, and we have 2 football games in a row. One of them has 800 people at it, and the next one has 950 people at it. Here's my question. What was the rate of, obviously it was an increase, right? What was the rate of increase? And pause for a second. I was asked on this one, was it geometric or not? Here's the important thing to understand. If I ask for a rate, then that assumes it's got to be thought of as geometric. Because I know what you mean. Maybe they're just going to be 150 more people at every game, okay? But if we say rate, that implies dividing 2 things. And that implies that this is geometric. Okay, so if I'm asking for a rate, I'm saying, assuming it's geometric. Okay. When you divided those two, which I'm sure is what you did, 950 over 800, then the only question is whether you're going to make the mistake of writing out the whole decimal. By the way, what was the whole decimal? 1875, okay. If you wrote that as your rate, that'd be wrong because that's the common ratio. What was the rate then? 18.75%. And then should I say increase? Yeah, that'd be good. Or you could say growth instead of decay. Increase or decrease is good, or decay or growth. Those are all good words to describe it. If you just say 18.75%, you really haven't said, was it going up or down? So, okay. Any more questions on that? Let's do one more, because this is probably one of the ones you could actually use in your real life the most. Say gas yesterday was $2 a gallon, and gas today is $2.04 a gallon. $2 a gallon yesterday, $2.04 today. Gas prices do that all the time. They go up, they go a bit down. It's always been kind of a mystery to me. The way I understand it, there's actually a law in Minnesota that gas stations can't charge more than a certain amount. Like, in other words, depending on how much they paid for the gas, they can obviously have a markup on their gas. It makes sense. You can't expect them to sell it for the same thing they bought it for. They're not making any money. But they don't want gas stations to go out of control, like, and just decide, well, if all the gas stations in Edina decide to raise their rate by 4 or 5 cents a gallon, nobody will be able to stop us, right? And if everybody's gas station price was 4 or 5 cents higher, then, you know, everybody just have to pay it. And so I think the law is meant to keep from gouging on prices. So they get to make a profit, but not too much, I guess. There's not too many things that are like that. Can you imagine if they did that on, like, the price of hot dogs? Because at Cub Foods, hot dogs are like, you know, 10 cents for the hot dog and like 5 cents for the bun. Like literally 15 cents you can buy if you buy a pack of hot dogs and a pack of buns. Like 15, maybe 20 cents, you get a hot dog. You go to the ballpark and it's like $7. Granted, they give you a little bit better quality hot dog, but holy cow. There's no limit on how much you can mark up a hot dog. There is on gas. All right, so hopefully you did 204 divided by 2, and you got what? 1.0 what? 2. Okay, so where you can make your mistake is by saying that's the answer, because it's not. If I wanted the rate of increase or decrease, you would say it was a 2% increase. I'm still a little nervous. Some kid's going to put 0.02. That'd be wrong. It's not 0.02. It's 2%. Okay, this is a decimal, and if they ask for a percentage, you have to give this. That's a percent, that's a decimal. So don't give that, give that. Okay? All right, one last one, and then I think we're going to be good. I haven't had you do too many these real-world problems, and that's where you're going to earn your A's or your B's on your test. So let's do a loan situation. Let's say that you borrow money to buy a car. Happens a lot. People want to get a car. They don't have much money in the bank. Cars cost, like, even a used one might be like $10,000, and they've only got $3,000 in the bank, so they have to borrow. Okay, so let's say that you borrow $7,000 to buy your car. So it's a loan. Now, let's say that you're going to be paying interest on this, because of course there's nobody out there who just lets you borrow the money for free. So let's say that it's 6.81% interest. First of all, write me the equation for that. Write me the recursive equation that would work for that one. Then put it in your calculator. I'll pause for a second while you do that. Okay, so you should have said U0 is 7,000. I hope you remembered. Real world problem, use U sub 0. UN minus 1, and then 1 plus 6.81%. And why would I just get that wrong right now? N is greater than or equal to 1. What did I do wrong? Well, 2 people know? Seriously? Mr. C in the back. That's right. Because what I did was 681% interest. So 0.0681. How far do you always move the decimal when you're talking about percents versus decimal? 2. Always 2. Okay. There we go. Now, you can put that in the calculator, right? Now, a loan you're supposed to pay off, aren't you? So, at this point, if we put this in the calculator, isn't it only going to grow? It's going to grow by 6.81%. So your loan amount's just going to keep growing and growing and growing. You're not paying anything off. I haven't taught you yet how to make payments. All right, so get everything into the calculator like you should, and I'll do the same, and then I'll show you how we can make payments on this puppy. Okay, I've got it in correctly. I hope that that's what you had too. Okay, now just let's think about this for a second. Logically, where should we make a payment? Well, that very top line wouldn't make any sense because that's changing what we start with as our starting term. That wouldn't do anything. And the bottom line, the line that's blinking right now, that's how much we're borrowing. But if we just subtract 500 or something, then we're making a $500 payment. But we're only going to do it once, and it's at the very beginning. And all of a sudden, instead of owing $7,000, we owe $6,500. So that doesn't make any sense. So that only leaves one logical place, and that's up in here somewhere. So if this is making it all grow, the balance of our loan is growing, if we're going to make a payment, it has to be at the end. And what do you think we should do? Subtract. So let's say we're going to make $1,000 payments on this thing every year. Okay? So we borrowed $7,000, and we're going to pay back $1,000 every year, but there's interest too. Okay? So then if I want to make a $1,000 payment, I just go minus 1,000. If I added 1,000, it would make my balance that I owe grow, and that doesn't make any sense. If it's payment, it should go the opposite way. That's why we're doing minus 1,000. We're going to make a $1,000 payment. Do you get that that's going to happen each time you go down a line, and it's going to subtract another 1,000 each time you go down the chart? All right. So now let's go to the table. If your table is in a weird spot, and it doesn't start with 0, 1, 2, 3, 4 on the left-hand side, you have to change your table settings. All right. So do you get that the balance is dropping? It starts at 7,000. After the second year, it's down to 6,000. And if it didn't have interest, it would be really simple. You would have started at 7, and you pay off 1,000 every year. Like if you borrow money from your dad, maybe he doesn't charge you interest. Okay, so then it's 7,000. Your balance will go to 6, and then 5, and then 4. It'd be really simple. But this has got the interest. That's why it's not quite so clean. Paying off 1,000, we still owe 7,476 because of the interest. Yes, ma'am. It's a good question. Whenever you're doing a real world problem, which this definitely qualifies, start with 0. And did I have I'm going to make sure mine's a 0. Yep. So yes, you should start with a 0 for real world problems. Why is that? Because at the very beginning, we borrowed 7,000. After 1 year, a bunch of stuff has happened. And what has happened is we had to pay a bunch of interest, but also we paid $1,000 of it off. So if we hadn't paid anything, the balance would be 7,476. But we paid 1,000 off, so now it's 6,476. All right? Now let's look down here. How about this? After 9 years, is it paid off yet? No. Remember, you have to think of this as at the end of the 9th year. We still owe $781. Okay. Yes, sir.
How would we find like this minus 1,000 if we're given if we're just given?
We will be telling you a payment. We'll tell you the payment. You don't have to guess and check on the payment. That would be really hard. What we'd say, the person's going to make a $200 payment. So all you have to do to add to your knowledge here, it's just in that very last line, in the middle of the calculator. You just have to know right at the end here, that's where you put your payment, and you make it minus whatever the payment is. That's it. Okay, so I do have one more thing to show you, though. On this table, oops, that was the graph. On this table, you get that it takes 10 years to get it paid off. Do you get that negative number means that they actually owe you money back? Does it make sense? You didn't have to pay as much as you did. And this actually happens in the real world all the time. Insurance companies will have people write a check that's too big. It's illegal for them to just keep that money because that's just being evil. You'd never know. You give them an extra $100 and they just get to keep it. So they have to return it to you. Do you get that negative 165 would be just like what they would have to mail you as a check? Okay. So, bottom line, how much did you actually pay for the car? It wasn't $7,000. Think about it. You borrowed $7,000, but you had to pay interest. So Do you get we made 10 payments by the end of this thing? 10 payments of $1,000. That's 10,000. But they did send us some money back. So if you want to know the total you paid, I'm teaching you more than you'd have to know for this test. But if you want, this is what we're going to next week. Getting really complicated. The total we paid is actually 10 payments of 1,000. It's $10,000, but they gave us 165 back. So we really paid $9,834.40. Anyway, the point is we paid almost 10,000 for this car. And that happens in the real world all the time. People think I'm borrowing 10 grand to buy this car, but they end up paying 15 grand. Why? Because of interest. That's why banks make money. There's nothing wrong with that. I mean, it's better than not having, actually one of the worst things for an economy is if nobody will lend you money. Because then nobody can buy anything. You know what I mean? It makes sense. It helps the whole system to have banks that are willing to lend you money. Because if they weren't willing to lend you money, how long would you have to save before you buy a house? Imagine that. Everybody'd have to be like 60 before they could buy a house. So, anyway. All right. Moral of the story, you just have one new thing to learn today, and that's how to throw a payment into your loan situation. All right, so let's just do one more loan. I want you to use your calculator, and you don't have to even write anything down for this. I'm just going to change some of the assumptions here. This time I'm going to say you borrowed $10,000 in 2015, this year. Remember, it's always easiest to think of it as happening on the very end, last day of the year, just to make it cleaner. So you borrowed $10,000 in 2015. Now, could you start with U sub 0? Yes. I would encourage you to, in this case, start with U sub 2015. Because then you'll be able to, I'm going to ask you, like, how much do you still owe in the year 2010 or whatever, okay? All right, so you borrowed 10 grand this year, 2015. Already you can change two numbers in your calculator. Next, we're going to say the interest rate is 9.2% interest. If your credit isn't very good, you're going to pay at least 9% interest on a loan. If you've got good credit, meaning you've always paid people back on time, then you get a better and better interest rate. It makes sense. If you know this person had always paid everybody back that they ever borrowed from on time, you'd give them a good deal on their interest. And if you're like, this guy rarely pays people back, you're going to want a lot of interest if you're going to borrow him money. So it makes sense that they're going to charge different rates for people that have different credit histories. The one exception to that, in my mind anyway, is if the poor person had a really awful thing happen, like they got cancer and they had no insurance, and all of a sudden they had lost all their money, and how could they have paid people back? And now they're healthy again, and there's always special situations. But in general, I think you get why credit ratings make a difference. You know it's true amongst your friends. If somebody has borrowed money from you and never paid you back, you don't want to give them money as much as your friend that's always paid you back right away. Totally different situation, isn't it? All right, so one more thing. I haven't told you one important thing. What's that? The payment. Yep. We can go with 9.2. This will be a 092. And I can put a 0 at the end here. It doesn't really matter. All right, let's make a payment of, let's try to get this thing paid off fast. We'll make payments of $2,500 each year. $2,500 payments. My question for you is, what do you still owe in the year 2017? At the end of 2017, you still owe money. How much do you owe? Yes. You got the answer? Okay. Let me look. Alright. I think it wants the multiply in there. Can you insert a multiply right after the n-1? Just try that for me. And do you have a minus the payment? I didn't check that. Okay. So I should change this because I suggested you go with U sub year 2015 is when we borrowed the money. So then I'm going to go to my table settings also and change that to start in the year 2015. If you were having trouble with your table, that might be the reason. You got your table settings changed? Try that. And then I'm going to go to the table. And in the year 2015, I owed 10 grand. At the end of 2016, I had paid off a bunch, but I'd had some interest. So bottom line is, how much did I still owe in 2017? You should have said, oh, this is going to be evil. Arrow over onto that. That's exactly how much you owe. It's rounded. And if we wanted the answer to the nearest penny, and you didn't put the 4 there, right here, then you wouldn't have got credit. Do you get the difference? If we wanted it to the penny, it's rounded. You shouldn't say 6694.6. You should say 6694.64. You have to go in there, and then you can see the answer right there. Okay. If you understood everything I was just telling you, then you know everything you need for doing well on your test on Monday. So your homework is a review worksheet, and I'll show you where it is. Was there any questions on this one? Saw some people squinting at the board, so it made me think that their answer was different. But, all right. Okay, so let's go look at the homework, and that's in here. And I also want to get a homework into the gradebook today. So in a moment, we'll be grading up yesterday's. All right, I don't want to have you skip anything because there's not that many questions, and you need to know this very well for the test. You do have a weekend also, so it's a doable, reasonable assignment. I don't think it's ever nice if teachers say, well, I can give you a huge assignment because it's a weekend. But this isn't huge. There's only 7 problems. Granted, there's multiple parts, but. Okay? All right. Now, I'd like to move to grading the old homework. So that's the end of the video.